use the square term on the market factor. So you already have the market risk premium. All you need to do is create the square term on market risk premium. Yeah. So then for this one, your regression, your y is still what? Your y is still the risk premium on your fund, but your x this time is this bunch, right? So market risk premium itself and market risk premium squared. Why? Because we want to see if it's band upward or band downwards, whether it's convex or concave. Basically, our goal here is to what? To see the coefficient estimate in front of the square term, right? Remember what are you gonna pay attention on? If this coefficient is what? Remember what we said last time? To see if these guys have market timing ability, basically whether their fund's beta increases as market goes up, so they're picking highly sensitive stocks as market goes up so that they can have bigger swings, right? Whether they have that ability or not depends on whether this coefficient in front of the square term is positive and significant, right? So this is where you look at not just the sign of the coefficient here in front of the square term, but also the p-value, whether it's a small p-value, right? Last time we said usually people use 5%, less than 5% p-value, great. If it's less than 10%, we'll take it, yeah, but not as significant as the less than 5%. Less than 1%, wonderful, yeah? So this is where you gotta pay attention on the nonlinear terms coefficient estimate. That's the first nonlinear regression, okay? And any question about the square term here? The second nonlinear regression is instead of using the square term and increasing, include the curves, we can include a term, a kink. And to do that, you gotta introduce a dummy variable, right? Dummy variable basically tells us when is a bear market, when is a bull market, depending on whether the market risk premium is positive or negative, right? So market risk premium positive, market is doing at least as good as the risk-free rate. We define that as our bull market. And vice versa, market is not even generating risk-free return. That's our bear market, yeah? And at each observation, you have this dummy variable defined based on the market risk premium, and then you create, so this is the new variable you create, is the dummy times, so that's what we call the interaction term, dummy times the market risk premium. So as you can see, when the market risk premium is positive, dummy times it is just itself. When it's negative, then dummy times it is 0. Okay? And then for your market timing nonlinear regression, all you need to do now is what? Your y is still the same risk premium, never changes. Your x this time is gonna be the market risk premium and the interaction term. So by doing so, what we're hoping is what? Trying to see if the coefficient estimate in front of that interaction term is positive and significant. Why? Because when market risk premium is positive, now your beta for the fund becomes what? The original coefficient in front of RM minus RF plus the coefficient in front of the interaction term, yeah, or what we call C. So if basically, can't draw here. If market is in Bayer territory, then coefficient is just itself because the interaction term is 0. Yeah? So that's why for your second regression, the coefficient in front of the interaction term becomes your attention point. You gotta see if this coefficient is positive and significant. Yeah? Whether it's significant or not, again, depending on whether it has a small enough p-value or large enough t-value. Okay? P-value you have to remember is 1.96, 1.64, but for p-value it's pretty straightforward. Just see if it's less than 5% or less than 1% or less than 10%. As a matter of fact, the same statistical significance applies to your Fama-French three-factor model or Kaplan models, coefficient alpha and beta. Same thing. You calculate their alpha, beta estimation, but it will also give you the p-values for each estimation. And whether the alpha is significantly different from 0 or not depends on whether that p is small enough or not. So same thing, anytime you run regressions, not just those nonlinear regressions, the linear one, you also need to look at the significance level. Okay? Otherwise, this one here, it shows a positive alpha a little bit, but because its p-value is so large, then this alpha, even though it's positive, is really not different from 0. Okay, so we call it insignificant.